Okay, let us just start our session. So this is basically it's about today we're gonna learn about linear algebra. Let me share my screen first. Okay, so just give me some time. Okay, so today we're going to learn about linear algebra. So basically, in anybody wants to learn about machine learning, so for the mathematical ground you'll have to learn three aspects of mathematics. Those are linear algebra, calculus, and some part of statistics. So here I'm going to teach you about linear algebra, first course in series of machine learning. So today we are going to okay, so today we are going to learn about system of equation, identifying matrix representation, singularity, linear independence, and calculating determinant. We are going to learn this uh, ahead. So basically today I'm going to discuss about the system of sentences, the equations, and system of equations as lines, linear dependence and independence, and lastly, a geometric notion of singularity. So moving on, here we can see some sentences. So I would like to first reflect on the real life things so that we may understand the mathematical terms properly by interconnecting them. Now, uh, okay. So suppose we have the three systems and okay, can I write? Okay, I write. Suppose we have three systems. Suppose I have the system one. There I have black rose, and we have the pink lily. So what can we see here? We have two sentences. Are you guys okay? So here we have two sentences, and basically it's two sentences, and we have also two piece of informations. Okay, so basically our goal is kind of from this system is to gather as much information as possible. So here we can see we have the two sentences as well as we can get two piece of informations. Suppose we have a system 2. Okay, what can we see here? Suppose we have a black rose and the black rose again. Okay, so what can we see here? We have the two sentences. Okay, fine, but we have actually one information. Okay, let me connect my charger. Okay, so moving on. What can we see here? We have the repeated information, basically one information. And next, moving on, if we have the system 3, Suppose we have okay, here black rows and the white rows. So black rows and the white rows here. Okay. So basically, again, we have two sentences, but it's contradictory information, because as we have seen before, we had black rows, but our rows can be black and white, fine, but in the particular situation that we are right now talking about. আচ্ছা হোল্ড অন, আমি কি রেকর্ড করতেছি? আচ্ছা করতেছি। Okay. So, but in this particular situation, it's the contradictory. And moving on, so basically, what conclusion we can come? It's a complete. It's a complete system. Um. By the way, guys, am I audible? Can somebody make sound? Okay, thank you. Okay, so in the system two, we can see it here. It's I mean, it's repeated. The information is repeated. So it is called redundant redundant system. And moving on, we had the contradictory. So this is called contradictory system. Okay. So here now, when the system is redundant, I mean, when the system is repeated or contradictory, that things will be called as singular system. So basically the thing is, and the complete system is called non-singular system. So basically the complete system is where we are getting all kind of information, there is no repetition and there is no many contradictory stuffs, we are getting all kind of information. That is a complete system, and it will be only this will be called singular system. And the rest of the things will be, I mean, this is basically a blind thing. I mean, the complete thing will be singular and the rest of the things will be uh, non-singular system. It's non-singular, and it will be non-singular too. Okay, so okay, sorry, I made a mistake. Basically it will be non-singular and these will be singular. Sorry, my bad. These will be singular. Okay, so what we learned, the complete system will be non-singular and the rest of the things will be singular. So non-singular system carries many pieces of information as sentences. So next we have examples with three sentences. Here we can see black rose, pink lily, and red orchid. Three different information, and there is no redundance, no contradictory. So it will be um, complete system. And next we have the two black rose and red orchid. We can see here the redundance, so it's a redundant system, uh, as in singular system. And the next one is to it will be singular system too. Okay, next we have the system of equation. So moving on, suppose we have three systems. In the system one, we have, I mean the equation actually. We have a plus b equal to 10, a plus 2b equal to 12. So basically, this will give us. Acha, let me write system 2. System 2 is a plus b equal to 10, 2a plus 2b equal to 20, and we also have system 3, equation 3. We have a plus b equals to 10, and we have 2a plus 2b equal to 24. Okay, so here we can see in the system 1, here we have actually this is basically a complete system, like I mean দেখেই বোঝা যাচ্ছে. Here we can see redundance. Anybody can tell how it's redundant or why it's redundant? Anybody wanna talk? Anybody? Yeah, you're right. Basically, that's the thing. So it's basically giving us one piece of information, like we saw before here. It was giving us basically one information. I mean the repeated things. So it was redundant system as singular system. So basically, this is also a redundant system, and here it's totally contradictory. So okay, we will move later. First, let us see this one. So it will give us unique solution, because if we solve this, I mean if we solve this situation, it can be solved, it can be literally solved, like uh, we can do some plus minus, we will get the answer. So guys, give me a second please. Okay, so after solving it, we have a equals to 8 and b equals to 2. So basically it's we are getting I mean all kind of information from here. So this is a complete system, and it will be non-singular. Next we have system 2. So as we told, basically it is actually a plus b equal to 10, basically one information or one equation, whatever you say. So basically we will get so many, I mean it will give us so many solution, as in like 0 plus 10 equal to 10, or like 2 plus 8 equal to 10. So we are getting, I mean 2 8, sorry 2 8, then we are getting, then we are getting 6 4 or 4 6, whatever you said, then 0 10. So basically this is giving us a lot of, I mean, the lot of solutions. I mean to say infinite solution. So it is infinite. Will give us infinite solution. So which means it's redundant and it will be singular as we saw before. And the system tree, for the system tree, it will be uh, for the system tree, uh, two equation actually contradict each other. So there will be no solution here, no solution here, and it will be as usual as we read before, it will be singular. Okay, so next we have the linear equations, linear and non-linear equations. So first the linear equation and non-linear. Okay, if I try to give a brief introduction, this is basically, suppose we have equation like a plus b equals to 10, or 2a plus 3b equal to 15, or even we can have floats. I think it's called floats, I mean the decimal. Suppose we have this. Basically it can have as many variables as, as we want. And in the nonlinear equation we can see we can have like suppose we have a square plus b square plus, sorry, b square equals to, oof, okay, equals to 10. We can also have the sine cos 10, arc 10, different stuffs. Or we can have a equation like sine a to the power 5 plus b to the power 5 equals to 15. Can have power also, or we may have 2 to the power a minus 3 to the power b equals to 0. Like, it can have power. Those will be, we consider them as non-linear equation. And linear equation is cute and beautiful. Oh my god, what I'm saying. Okay, so from here we can easily extract information, we can manipulate. So basically, more or less, these are the, difference between them. Next we have uh, so we had three equations. We can represent those equations as line in. So suppose we have uh, a plus b equals to 10. So if I draw this, we had so many solution for this, like as I told before, like 0, 10, or we may have 4, 6, or also 8 too. Like it can be solved in many, I mean, with many elements. Okay, so if I try to draw the line, suppose we have 10 comma 0 here, we may have, suppose we have 8 comma 2. Also we have, um suppose we have 4 comma 6, we have like 0 comma 10. So it can be, it gives us a straight line. Sorry, it actually এখানে না, এটা এখানে. Okay, so something like that. So basically we are getting so many solutions for this one equation. And we also had equations uh, like this one. So if we want to calculate this, we can have 0 plus 2 into 6 equal to 12. So we are getting 0 comma 6 here. We may also get, we can have 8 plus 2 into 2 equal to 12. So it will be 8 comma 2. We can have solutions like this for this. So let us just draw it. uh, so basically the thing that I'm trying to point actually, suppose we have this line for this, where we have a uh, point like 8 comma 2. For these equations we also have these equations, and when we are trying to solve these two, we're trying to solve these two, so it will intersect in this point, like both have a common point, 8 comma 2 and 8 comma 2. So basically this is giving us like a unique solution. I mean this system, we are actually here we are representing those equations that we read before. We are now representing them in lines, and I'm trying to depict the things. So basically, but when it was like a plus b equals to 10, and if we have the 2a plus 2b equals to 20, I mean for that previous second equation, the lines will be this. I mean like it will be the redundant system. And next the we had third system, that was, suppose we have a plus b equals to 10, and we have 2a plus 2b equals to 24. So what we saw, it was contradictory because the reason, as we gave a real life example before, like white rose and black rose, both were rose, but they had a difference. I mean, uh, as we were actually, I mean, counting only black rows. So in that angle, that was contradictory. So here it is also contradictory. So basically, it will give us parallel line like this, and this will never meet. These lines will never meet, never intersect each other, so it will have like no solution as they didn't intersect. Are you guys there? Can you guys respond for a bit? Are you sleeping? Okay, this is my first ever session. I don't know what I'm doing, but I'm a bit nervous too. Okay. Uh, so what's the conclusion? So the conclusion is in this equation, it's okay. So the conclusion is in this equation or the plane that I draw here, it is. I know I think my board is a bit messy, but I will try to do it more specific from the upcoming sessions. Anyway, so it has unique solution. It's a complete system. Also it's নন সিঙ্গুলার কমপ্লিট মানেই হচ্ছে নন সিঙ্গুলার মানে একদম চোখ বন্ধ করে it's non singular. uh then again we had uh sorry not this one, a plus b equals to 10 and a plus sorry 2a plus 2b equals to 20. So it we as we saw it's a redundant system because this is basically a one information, even though it's two line but it's actually one information. So uh, okay, so let me just so for this, okay, so we what we can get from here, it has infinite solution, infinite solution, and it is actually first, I mean like same as the first line. So basically this is indicating it's a redundant system, and also it's singular. Anything except complete is like singular, I mean it's singular. Then we had this one, uh, it has no solution, no intersection. As it has no intersection, it's a, so it's no solution, and they never met. And also the second equation contradicts the first one. Okay, so moving on, we have what's in there. ওকে আমরা এটা মাত্র পড়ছি, এটাও মাত্র পড়ছি, প্যারালাল, ওকে এটাও মাত্র পড়ছি। Okay, acha, let's see now. Linear, linear dependence and independence. So for non-singular, suppose we have a plus b equals to 0 and we have a plus 2b equals to 0. As we can see, it's if we, portray these as matrix, we have 1, 1, 1 and 2. So basically like this, and we can see it is, independent, like it's not dependent on this one. And for the singular, so this is a complete system. And for singular, as an example, suppose we have a plus b equals to 0 and 2a plus 2b equals to 0. So basically, as we saw, it's basically one information, and this is dependent on this. Basically, the second equation is a multiple of the first one, and second row matrix like 1 1 2 2. Basically the second row of the matrix is the dependent on the first one. That's what I'm trying to say. So here the rows are linearly dependent. It's dependent, so it's dependent. Okay, so now we are going to see. Okay, now we're going to see geometric geometric notion of singularity. Okay, suppose we have equations previously, like suppose we have a plus b equals to 10 and a plus 2b equals to 12. So we solved it before. It was a complete system. It had an intersect point and unique solution. So basically, acha, suppose next we have system 2. We have a plus b equals to 10, 2a plus 2b equals to 20. And let us, what the heck, what's happening? Okay, so we had something like that, and next we had system 3, that was a plus b equals to 10 and 2a plus, I don't know আমার পেন এরকম করতেছে কেন, 2b equals to 24. So it was something like this. So as soon as we make the as soon as we make this constants into zero, যদি আমরা জিরো করে দেই জিনিসটাকে, so basically it these things will be come here. The solutions will be zero. It will not affect here. It will not affect here. Ultimately, the solutions will be zero. So, zero হওয়ার কারণে this will come into the 0 point. It's the same. It will go with this, and here, okay. So here it will be. So when I will do this into zero, these all will be zero zero. Suppose the constants are the zero, then it will go with this. The two lines will pass through the 0 point. So a change has happened here. Anybody can tell me what's the change you can see here? Anybody? Anyone? What happened here actually? The system has shifted. Any guesses? You can say no to. Basically, yeah, kind of that. Think more. Okay, let me tell you. Previously, here, okay, see, previously we had, okay, so when it was like this, previously it was a contradictory system, right? As soon as we made the constant zero, then it became redundant. See, like this one. Redundant হয়ে গেছে, কন্ট্রাডিক্টরি থেকে এখন পুরো redundant হয়ে গেছে। বাট দ্য থিং ইজ, যতই রিডান্ডেন্ট হয়ে যাক, মানে হচ্ছে যে এটা কন্ট্রাডিক্টরি থেকে রিডান্ডেন্ট হয়ে যাক বা রিডান্ডেন্ট থেকে কন্ট্রাডিক্টরি হয়ে যাক, হোয়াট এভার দ্য থিং ইজ, ইটস স্টিল the singularity is still the same. It has not become non-singular. This two has no similarities or connection like this one. It was like non-singular, but these two, it shifted from contradictory to redundant. Okay, fine, but it's still same, it's still singular. So what I'm trying to point out is that তুমি কনস্ট্যান্ট চেঞ্জ করো আর যেটাই চেঞ্জ করো না কেন, তোমার জিনিস হচ্ছে তোমার এই সিঙ্গুলারিটি অ্যান্ড নন সিঙ্গুলারিটির, মানে বেসিকলি একটা জিনিস ওর একটা সিস্টেম সিঙ্গুলার নাকি নন সিঙ্গুলার এটা ডিটারমাইন করার জন্য আমার কনস্ট্যান্ট কোনো ম্যাটার করতেছে না। দিস কন্টেন্ট দিস cons the heck, these constants doesn't matter. It doesn't affect on either it's singular or non-singular, like to determine. It's not affecting actually. So next, I'm going to end it soon. I will take 2 minutes more. So singular versus non-singular matrix. Okay. So as we had the our complete system a plus b equals to 0, and we had a plus 2b equals to 0. So এটাকে যদি ম্যাট্রিক্সে সাজাই, so like 1 1 and 1 2, so it's 2 into 2 matrix. I mean the row and column, it will be row, it's column. Okay, so and if we have a plus b equals to 0 and 2a plus 2b equals to 0, so we have the 1 1 2 2. So this is how we write as matrix. And the thing is, this is acha, can anybody guess, I mean what kind of system is this, singular or non-singular? It's non-singular, and this will be singular. Okay, so in the next class, next session, we will uh, explore the rest of the topics along with determinant. Um, okay, so I hope you guys learned something at least.